So hey, hello guys, welcome back to my channel. This is Sanjay here. So in spite of some many requests from my friends and etc, put some chemistry videos also. So I just put some 2 videos on max. Okay, so now I plan to put some chemistry videos. Okay, so this is March time. Okay, so you will get your board exams, for class 12 by May month, I guess. So I thought, why not do some questions or else, like, if possible, every question of the NCERT textbook, the Intext and the book back, and also the previous year questions of the organic chemistry part, the second volume one. So here I am starting the Intext questions of HaloAlkanes and Haloarenes. So this is Intext questions of RX. I just said in short form only. Okay, RX, sorry. So RX refers to alkyl halides and ARX equal to aryl halides. Okay, simple way of writing. So first question, if you see on the 10.1, we will see 10.1. okay, the first question is like okay, I'll just put the question on the screen, else you just refer the NCERT. Okay, 2-chloro 3-methyl pentane. Okay, so 3-methyl-pentane means pentane is the main parent chain, so you just draw the bond line formula. Okay, that will be easier. Okay, this is the pentane structure here, correct? Okay, my pen is not writing, I don't know why. Okay, methyl pentane, 3-methyl, so just randomly. Okay, if you come anyway, this is going to be third position. Okay, 1 2 3 1 2 3. Okay, 2 pair chloro. Okay, so it will be chloro here, that's all, simple. Okay, bond line you can leave methyl acid. Okay, 2 chloro 3-methyl pentane. Okay, second question is 1 chloro 4-ethyl cyclohexane. So the parent chain is cyclohexane here. Okay, so this will be cyclohexane 4. Okay, 4-ethyl, so it will be, we'll just consider some random position as 4. Okay, we'll just consider this position as 4, so 4 ethyl. Okay, and 1 chloro, so if this 4 3 2 1, so this will be 1 first position. Okay, chloro, correct? Yeah, correct. So the next question is 4 tertiary 4 tert-butyl 3 iodide heptane. Okay, heptane structure is this one, correct? 1 2 3 4 5 6 7. If you keep on writing CH3 CH2 CH2, it will take years. Okay, heptane is this one, 1 2 3 4 5 6 7 3. Okay, just randomly write, this is third position, right, iodide. Okay, and fourth position is tertiary butyl, so it will be tertiary butyl means like this only, correct? This is tertiary butyl, 1 2 3 4 carbons, tertiary position, this is tertiary position, correct? This will be tertiary butyl. Now the last question is the last but before question is 1,4 dibromo-butene. Butene means this will be butene, means this is structure of butene. Butene means this is the butene structure, and 1,4 dibromo, so it will be here 1 bromo, here another bromo, so 2 dibromo, correct? So the last question is, okay, somewhat I just think I'm just going fast. Okay, but this is, you can consider like kind of a revision. You can consider the NCERT solutions, the NCERT questions. Okay, so by this time you have to be really fast. Okay, this is not teaching. Okay, just revision and solving questions. Okay, but that should be not too fast, not too slow. Okay, while learning you can be slow. Okay, so the last question is 1 bromo 4 secondary butyl 2 methyl benzene. Okay, methyl benzene means you have to draw benzene first. Okay, this is methyl benzene, so you can consider this to be methyl position. Okay, methyl benzene. Okay, sorry, 2 methyl benzene they have considered. Okay, so generally we consider this as first position. So that is why I'm considering this as second, and 2 methyl. Okay, 2 methyl 1 bromo, so this will be 1 bromo, correct? And 4 secondary butyl. Okay, 1 2 3 4 secondary butyl. Secondary butyl means this one, correct? Secondary position is butyl, 1 2 3 4 butyl, correct? Okay, so this is structure of 1 bromo 4 secondary butyl 2 methyl benzene. Okay, this is 5 questions of 10.1. now let's go to 10.2. Okay, 10.2 is a theory based question, like why is sulfuric acid not used during the reaction of alcohols with Ki. Okay, theory question I'll try to if I just keep on explaining, you will not understand. Either I'll just put the answer in the description box, or you can just check it in Google or something. Okay, because if I keep on explaining, you will not understand like in one go. Okay, it will take time, so that is why I'm leaving this. And if you have any doubt, you just ask in the comments. Okay, 10.3 is a bit interesting. It's actually different dihalogen derivatives of propane. So what is propane actually? This is propane, correct? Oh my god. Okay, this is propane. So dihalogen derivatives of propane. Okay. So dihalogen derivatives means what? Like it should be for example, 2 chlorines, 2 bromines, like that it should be. Okay, we will use it like 2, 2 dichloro, 1, 1 dibromo, like that. Okay, like that you can just, okay, this is actually free radical mechanism of alkylation of halogenation of alkane, correct? Alkane is there when you just put it in H nu and Cl2, and you just put it, you will get different free radicals like this one, and the another is same only. Okay, so upon halogenation you will get, you will get this Cl and you will get this Cl. Okay, like that, like this is monohalogenation, but they are asking dihalogenation. So for dihalogenation you just consider propane, this is propane. Okay, where are the free radicals possible? Here only 2 radicals possible, so it will be so this will be one Cl, this will be another Cl. This is possible. Another thing is possible is this one. Yeah, here one Cl, here another Cl. That's all. No, only 2 such are possible. So these 2 are possible, correct? Okay, some more are also possible here actually. I just forgot. I just remembered now. Okay, so it will be they are not asking that the halogen should be in the same position, so it can be like this also, right? Cl 1, 2, 3. Yeah, this is also possible. And one more structure possible is this one, like this is one Cl here another Cl. This is also possible, right? Okay, like for your practice, you just do one thing. You just in your home you can just name these structures, and maybe if you can write it down in the comment section. Okay. So this will be 4 isomeric alkanes, dihalogenation of propane. Okay, so next question is on 10.41 Intext question we are doing now. So among the isomeric alkanes of molecular formula C5H12, okay, C5H12 is pentane, like 5-membered carbon. Identify the one that on photochemical chlorination yields. Okay, basically what they're asking, this is one alkane. Okay, first we have to write all the isomers of this. Okay, then only we understand. Okay, I will just write the isomers. Okay, this is one isomer, this is main isomer of pentane, and another one, what you can draw, this one you can draw, and another one is this one. Yeah, this one you can draw. Oh, it's the same thing, sorry. This one you can draw, correct? So the next question is 10.6. we'll just move. Okay, and the video is getting lengthier. Okay, just finish fast. So increasing order of boiling points they're asking. So this is bromomethane, this is bromoform, this is chloromethane, this is what, dibromomethane, correct? So simple. Okay, these are all methane. Basic parent chain is what, methane only, right? CH3 only. So basically you have to judge with the molecular mass. If the alkyl part is same, if the alkyl part is different, then you have to go with branching. And if the alkyl part correct. So if you see among this all, which has the highest molecular mass, the second which is has the, I'm bad addition. sorry. So this is the first highest molecular mass, this is second, and third is this one, and fourth is this one, correct? That's all. Means this is the highest molecular mass, means highest boiling point. Okay, so understood, right? So here if you see two two parent chain has the same, two compounds the same parent chain, propane. Okay, so you have to judge with the branching. Okay, if the some branching is present, it will have lowest boiling point. Okay, so highest boiling point will be which having highest molecular mass. So this is having highest molecular mass, so this is the highest boiling point. Okay, second will be, these both are same molecular mass, right? But branching is there here. Okay, so this will have lowest, so this will be second, this will be third. Okay, the theory part I will just do the NCERT, or I'm just planning to put a one-shot video kind of thing before the board exams. I'll try, so I just explain it there. Okay, that's all about 10.6 simple boiling point question. Two things to remember. Okay, if same parent chain is present, see the molecular mass. If different parent chain is present, see the branching. So if highest molecular mass will have higher boiling point, and if branching is there, then it will have lowest boiling point. Okay, simple. So basically these three are the isomers of pentane. Okay, the first question they're asking, when we monochlorinate all these structures. Okay, the first question they're asking, the one isomer we have to find, that should be single monochloride. Okay, means what? When we chlorinate any one of these, it should generate only one monochloride. Okay, the basic mechanism of the chlorination, what will happen, for example, if you take propane, okay, it will yield this product, and also it will yield this product, this product, correct? So basically mixture of products will get as a result of chlorination. But they are asking, when we chlorinate any one of these three isomers, we should get only one chlorine. Okay, means what? Actually we have to see the mechanism. Okay, not exactly needed. Okay, but what is happening, at least you have to know. First the chlorine, whatever we are getting chlorinated, we'll just write it. Okay, you just don't need to memorize and all, just learn it. Okay, learning is always good, Okay, this is Cl, and one more Cl molecule is here. Okay, first it breaks into radicals, so you get Cl dot plus Cl dot. And for example, propane, if you take, okay, this propane has how many hydrogen? One hydrogen here, one hydrogen here, and three hydrogen here, and three more here. Okay, what happens here? This hydrogen is left as a radical. For example, this hydrogen leaves. Okay, then what will happen? One radical is formed here. Okay, it leaves as H radical. Okay, this radical is formed. Okay, and even if this hydrogen leaves or this hydrogen leaves, anyway same radical only it will be formed. Okay, and plus what else? What is another radical is formed? If this hydrogen leaves, you will get this radical. If this hydrogen leaves, you will get this radical. But this radical, this structure and this structure are the same, right? So we generally consider only these two. And if you when chlorine radicals join with this, you will get this one. You will get this one, and also you will get this one. Okay, it's just messy. Okay, you just know, like, the halogen molecule breaks into radicals, and this is not the exact. Okay, somewhat similar only it will happen, but I just said for understanding. Okay, and alkane molecules lose hydrogen as radicals, so as to form a radical on itself. Okay, like this, and finally the combination happens like this happens, and some byproducts are also formed, like this radical and this radical will be combined, like that stuff happens. Okay, so now what happens? Let's erase it 1 minute. Okay, so what they're asking, among these isomers, first we have to form the radicals. Okay, so here you can possibly get how many radicals? 1. So here this radical you can get, and one more radical. This radical you can get. This radical you can get. Only 3 radicals are possible. Correct. If you form radical here, again this structure is repeated. If you form here, it will get repeated. So 1 2 3 radicals are possible. Now for this one, if you see, okay, this one here, one radical possible, here one is possible, so one more is formed here in this position, and this is formed here also one, and you'll get this also, this radical. Okay, but the problem is here, see, this and this are same if you consider. Okay, how? Okay, you just name you just name it. Okay, 1 2 3 4. Okay, so two second position are having a methyl group. Okay, correct. Name this also 1 2 3 4, second position having a methyl group. Okay, so if you see this molecule, you name from this carbon, okay, 1 2 3 4, second position methyl, correct, only one radical is there. Here you name from this one, 1 2 3 4, second position methyl, radical is there. Those are same, but if you see these three are different. Okay, why I'm saying, okay, you just name it here. Okay, however you want, you can name. Okay, 1 2 3 4, third position radical is there, 1 2 3 4, second position radical is there, 1 2 3 4, fourth position radical is there. Okay, so all the structures different, only this structure does not repeat. Okay, so you're getting 4 isomers here, and if you see here, there's no space to draw. Okay, if you see here, only this position has the possibility of, sorry, here there is no hydrogen. Okay, this position, central carbon is there, all 4 is filled up with methyl, so no hydrogen is there. All these 4 methyl group has hydrogen, 3 hydrogens are there, but fortunately all those hydrogens are identical. Can you understand? If you form radical over here or here or here or here, all it will be same only. So only this molecule, okay, this molecule has one isomer, which on yielding it will give only one chlorinated single monochloride. Okay, do you understand what happens? Only one molecule, only one isomer among these 3 exists, such that single monochloride is formed. Okay, similarly the next question they're asking 3 monochloride, 3 what we saw here now, 1 2 3. So this one, the first one, neopentane, correct. And the next one they're asking 4 isomeric chlorides. 4 means what we saw just now, 4. That's a simple answer. So they're asking one isomer you have to name that will yield a single monochloride, means this one. 3 monochlorides means there should be isomers. Okay, means this one. 4 means this one. You understand? Simple. So the next we will see 10.5. Okay, 10.5 is basically reactions part. The first one is this OH. If you refer the book, okay, SOCl2. This is what simple substitution reaction, like preparation of halogens. You have seen it, RX, preparation of RX. You will simply replace the OH here. That's all. Chlorine will come here. Understand? Simple reaction only. Second one, this is one of the most important question. Okay, just make a note of it. Okay, this benzene ring, NO2 is attached here, and CH2 CH3. Okay, this upon Br2 heat. Okay, what is this actually? Br2 heat means, generally Br2 heat means it is a halogenation. Okay, free radical halogenation. If you supply chlorine in presence of sunlight or H neo, okay, that is actually representing the free radical halogenation. Okay, so now which is the halogen part here? These are not the halogen part, only this are, which is the alkane part here. Okay, which will get chlorinated. This is the alkane part. This will not get chlorinated because these are double bonds. So alkane only will undergo monochlorination, like that, correct? Like the double bonds also undergo chlorination, but under different conditions. Okay, here it is given heat. Okay, but now the problem is, where will the free radical be formed? I just explained the previous few minutes back, like how the chlorination will happen. Okay, first the chlorine molecule, here bromine will separate into bromine free radical. The alkane also lose hydrogen radical to form radical on itself, and that will combine with the halogen radical. then it form halogen, correct, alkyl halide, correct. So here the possibility of forming halogen is 2, okay, like 2 positions it can form halogen, correct. One is here, okay, this hydrogen, this position, okay, or is this position. Why? Because here 2 hydrogens are present, here 3 hydrogens are present. Any one hydrogen can leave to form the radical, but you can see this position, okay, has no hydrogen, because see 1 2 3 4 or 4 positions are filled, so only 2 positions are free radical. Now which is dominant, which will be formed more, okay, because in the question they given, actually I did not read the question, draw the structures of major monohalo products, okay. Major, how will we say major thing, okay. Generally in organic chemistry, major products are decided by the stability of the intermediate form, okay. Generally, okay, not always. Major means always does not imply stability, but in most of the cases, okay, at least for the board exam you can consider, why, okay, this free radical formed here is more stable, I'm saying, because why. So if you see this benzene double bond here, right, this and this is under resonance. I'll just draw and show you why, okay. Wait. So here this is a structure, right. So if you see here, free radical will be formed here, correct. This is a free radical will be formed here when you remove one hydrogen from here, correct. And that is one possible structure. So if you see, for example, consider this to be free radical, okay. So this bond here, right, this bond here, it will break, okay. Like I'm showing you the resonating structure. Actually this will not happen in reality, but there is a resonance possible, I'm saying, okay. Resonating structures are not reality, right. Only reality is hybrid, okay. That 11th standard you should have read this basic concept. So if this breaks into free radical, one radical will be formed here, another radical will be formed here. This radical and this radical will get bonded, so you will get this one, double bond here and radical here, correct. So this is under resonance. So but if you see this structure, okay, here if you see this NO2 is here and this ethyl group is here, okay. The other possible free radical will be formed here, okay. But if it is here there's no resonance taking place. If suppose free radical is present here, okay, this bond is far away, correct. Resonance basics, okay. That is why this is the major free radical getting formed, okay. This, so because of this, the question is what we had this is the question. When we brominate it, the free radical is major found here, bromine will attach here, okay. That is the answer. Here attach, bromine will attach here, okay. I'll write clearly once again, wait. Yeah, so this is the structure formed, okay. This is the final answer. The next question is this one, okay. This here OH group is directly attached to the ring, and here but methyl group is attached first, then OH group is attached, HCl is reacted with heat, okay. What will be formed, okay. So this is basic preparation of alkyl halides from alcohols, you can say. The first reaction you studied in this chapter, okay. So if you have read the whole chapter, okay, you should have studied this SN2 reaction, SN1 reactions and all, correct. So what is basically happening there? Substitution cannot happen at this place, okay, at this position. Basically at this position substitution cannot happen. The reason is that there are 4 reasons actually. So you have some steric hindrance, and phenyl cation is unstable, and many reasons you should have studied, okay. So due to those reasons substitution will not happen here, okay. So this will remain unchanged. So this is not directly attached, it is first attached to methyl, then to OH. So the answer will be simple, okay. pH it will be here. I am just writing benzene as pH, okay. So OH will be here, and Cl will come and substitute the OH one, okay. That's all. This is the final answer, okay. Yeah. So the fourth question is this one. This structure is given, okay, and HI is said to react with this, okay. So simple, this is what addition of iodine, this halogen to double bond, okay. This is what Markovnikov rule, right? So it will iodine will get attached to that carbon where it is substituted, means less number of hydrogens that are there. Here if you see, okay, now there is a catch over here. You cannot use Markovnikov's rule directly over here, okay. Yeah, okay. So in this carbon, if you take, you are having one carbon here, and one double bond here, only one hydrogen is present, correct? But in this carbon, if you see 1, 2, 3, 4, all the hydrogens are lost, okay. So basically here the less number of hydrogen is present, so iodine will attack this position. So the answer you will get this one, okay. So this is the answer, okay. Why I said Markovnikov will not work here is because I thought both carbon same number of hydrogens are present, okay, but that's not the case. I misunderstood, okay. If at all Markovnikov's rule does not work, that we have to go by the mechanism, okay, that I will say in the coming examples. Wow, the next question is very, very simple. Fifth question, okay. Very simple reaction. This is a direct Finkelstein reaction. Because alkyl iodides cannot be formed directly, we have to first form alkyl bromides, then substitute with Na in presence of acetone. Acetone is left over here. It's okay, you can just add acetone if you want. So you will get what? The product will be this one. Simple direct question, okay. So these direct questions you should not leave, okay. So this question is what? Next question, okay. Sixth question. This compound is double bond is given, Br2 is given, heat is given, okay. So heat UV is given. That means you have to do only free radical halogenation, okay. Free radical halogenation means you should not touch the double bond, okay. So where are the free radicals possible, okay? Free radicals possible here, or here, or here, or here, or can be also possible here, okay. But the problem is you have to choose the more stable free radical, okay. You just take it like this way. If you see the bond is here, free radical is formed here, okay, then it's more stable. Why? Because again allyl free radical. This is known as allyl free radical. Allyl means double bond at carbon should be there. The next position of the double bond carbon should have a positive, or okay, generally we say that next position of the double bond at carbon is the allyl position, okay. The allyl position is most stable, okay, because due to resonance, obviously. Again, the double bond is split into free radical, and these two free radicals will join to form the resonance. If you want to highlight the resonating structure also, so you will get like this one, free radical is present, okay. Due to this is stable. So if the free radical is formed here, then also the same position, okay, means I am saying this one. See, this is again stable due to resonance. Why? Because see, yeah, you can see. So the final answer will be, we can just take anything. So final answer will be Br touching here, okay, this position, allyl position. So 10.7 is basically they're asking they're given set of two compounds, okay. You have to identify which will undergo SN2 faster, okay. First one is this one, or or this one. Obviously if you see SN2 means what? 1 degree is greater than 2 degree greater than 3 degree, correct? Rx. So here which is 1 degree, this is 1 degree, this is 2 degree, so this will undergo SN2 faster. Simple. Second one is this compound, okay. This is what? 2 degree, this is 3 degree. 2 degrees obviously will go undergo faster, so this is SN2. See, simple questions only they'll ask in board exams, okay. In competitive exams, some trickier part, there also the questions will be simple, but the many parts will be tricky, okay. Next one is, next one is this one. See, this is a bit trickier, both are 1 degree only, okay. But while attacking SN2 means what? Actually something will come and attack this molecule, and bromine will leave, something will get substituted, right? That is SN2, right? So what will happen? steric hindrance should become like it should be less, okay, then only it will happen. So when this bromine will leave, this methyl group is present far away, but this bromine methyl group is present will pass, okay, as pass, okay, it means nearer only, okay. So in this basics, this will undergo SN2 faster. Or you can say one more reason also, okay, but this is not in your NCERT level, so I don't know if you can write it or not, okay. What does that means? When this bromine leaves, okay, a positive charge will be formed over here, okay. This positive charge can rearrange here, okay. That rearrangement will happen only in certain conditions that we will not discuss here. Something rearrangement will happen. How means, for example, this leaves, okay, this positive charge is coming over here. Now this will rearrange, hydrogen shift will happen, okay. Plus this is what 3 degree. So 3 degree means SN1 will dominate, correct. So SN1 will dominate, correct. So something will substitute here, okay, some Y group. But in case of this one, if at all bromine leaves, plus charge will be formed here. It cannot rearrange over here. Just hear it. Don't ask me why and all, okay, because it will go beyond the NCERT level. Rearrangement is not in your syllabus, okay, it is in there, the JE syllabus. So you can say this reason, like, just know it, this compound, it will undergo easily SN1 then SN2. That is why this is possible. Or you can say the steric hindrance reason. This methyl group is sterically hindering the bromine without leaving. Means something will come and attack. While attack is happening, this methyl group is a hindrance. But here, methyl group is hindrance both the cases. But here it is more hindered because it is present near the bromine. But here it is less hindered. Simple reason, okay. So similarly 10.8, if you consider, they are asking SN1, okay. Here SN1 means 3 degree greater than 2 degree greater than 1 degree. That is SN1, right? So here it is 3 degree, this is 2 degree. So this will dominate SN1. This question, this is 2 degree, this is 1 degree. So this will dominate. Simple questions, okay. So the next 10.9, it is based on a set of, this is a beautiful question among all the 9, okay, I am saying, okay. I am just now going to teach how to judge the products, this is not roadmap questions, okay. Some set of reactions will be given like this, okay, arrow mark. You have to guess the products, or they may ask to guess the reactor, what is this, reagent also, okay. So the question is, this bromine, this cyclohexyl bromide, okay, this react with Mg. This is what actually, this is some Rx, correct. Rx plus Mg. Rx plus Mg means what is happening? Preparation of Grignard reagent, that is Rx plus Mg should give you what? R Mgx, correct. This is Grignard's reagent. So here this will give you A will be simple. A will be this product, okay. RMGX means it will be MGBR, simple, okay. Now the B they are asking. B is happening what? When this A reacts with water, they are getting B. This simple reverse reaction, okay. From an alkyne, it's not reverse. From alkyl halide we form a Grignard's reagent here. When you react with this H2O, this reaction you have to remember, okay. It's given in NCERT book only. Like RMGX, when it is H2O reacting with H2O, I'm just writing over here, okay. What will happen? Alkane will be formed. Here this is the R part, this is the Mg part, this is the X part. Like the reaction, general reaction is Rx plus RMGX plus H2O. If it's reaction, it will give simple, okay. Simple RH will be from RH means what? Alkane, and MgOH X, this is the complex compound, leave it, okay. This is the main part, this is the alkane will be formed here, which is the alkane part, and this part, right. So simply after reacting this H2O you will get this compound, okay, this, and the remaining is MgOHBr. If you want to write this one, write, or else no need. So this is the B, okay, simple. So this is one set of reaction. The next is given, wait. So the next set of reaction is this one, RBr plus Mg, and D means dry ether, okay. This giving C, and when it reacts with D2O. D2O means what? Hard water, correct? H2O like D2O is giving this one. Okay, now I'm saying how to decode this. Okay, so this is the general method. Okay, in this kind of reaction you have to come reverse. Okay, so I'll just say, okay, now RBR they've given and Mg they've given, so C will be what? C will be what? Sorry, C will be what? This will be RMgBr, correct? So now you know RMgBr, but when it's reacting with D2O, is giving this product. Some 3 alkanes are there. Okay, sorry, 3 carbon is there attached with this deuterium. Okay, now you have to think like this. Okay, first, generally when RMgBr react with H2O, okay, what happens? I said just now, it comes as alkane. Okay, here R is there, here also R is there, means for example CH3MgBr if you take, okay, and you react with H2O, what are you getting? CH4. okay, means one carbon is here, the same number of carbon is here. Neither the carbon is number of carbon is reducing, nor it is increasing. So you understand the pattern. Okay, this number of carbon should be same. So here it is R, here 3 membered. So this R must be 3 membered carbon. Okay, simple. Understand this. Next pattern, RMgBr, if you consider plus H2O, what are we getting? RH. H is actually what is happening. H2O is H, OH. This H is attaching with this R. Okay, mechanism is not like this. Okay, obviously, but just to understand, I'm saying this H is attaching with R. Okay, so what is will happen here? Similarly, if you take RMgBr plus D2O, D2O means what? D comma OD, correct? This D will come attached with this R. You will get what? RD. Similarly, something similar is happening over here also. This RMgBr is reacting D2O. D is coming attaching with this R, correct? So simple. What R must be what? Guess. R must be what? R must be CH3, CH3. Here it will be MgBr, correct? Then only when D2O reacts, this R part, okay, this R part will attach with this D, giving this product. Understand? Like this only you have to decode. Okay, you have to come with the reverse process and all. Okay, you just something of this kind is given, then you have to write the original reaction, write your own example, and find what is happening. Okay, so the next set of reactions is this one. Okay, 3 set of reactions I have given. Refer the NCERT. Some R dash of X. Okay, sorry, R dash X. That with Mg, what will happen? D will be, okay, we'll just go this side. Okay, R dash X react with Na. Okay, what is the general reaction? Rx plus Rx. If you consider, what will happen? This is what Wood's reaction. RR will be formed, correct? This R and this R will get attached. Similarly, if you see, can you find the the symmetry over here? This symmetry means, can you guess it like this X is there plus this X is there, this R and this R, this part is getting attached to form this one. Can you think like that? Okay, so yeah, you are right. Okay, so this is the R dash X part. So if this is R dash X part, when you react with Mg, what will happen? This part, okay, reacting with Mg, what will happen? RMgX. Okay, Rx plus Mg will give RMgX. It's RMgX. Okay, when it reacts with water, okay, water is here, what will form? That's no it all. Simple. See, the reaction is repeating. RH will be formed. Means what? This is formed. That's all. Simple. H is obviously here, but H will not show in the bonding formula. What is this? Isopropane, correct? Okay, just propane if you consider. Okay, this is the answer. Okay, can you understand what I'm doing in this set of reaction? First I'm identifying what reaction is that, and next I'm identifying write the original reaction like in general form, like using Rx and all, and then give an example to yourself and think what is happening, and decode the reaction with the opposite way. Don't worry, in the further chapter also you will get many questions like this. In this chapter only, when we discuss previous year questions or in the book back questions, you will get many questions. I'll just tell how to decode this. Okay, so the Intext questions are getting over here, I think. Yes, okay, yeah. So the next video we will see the book back questions. Okay, until then, take care, bye bye.
So basically, if you see here, when H2SO4 is used, okay, actually in the reaction ROH should react with Ki, it should give alkyl halide, okay. But H2SO4, when it is used, H2SO4 is one of the strongest oxidizing agents. As you can see in the reaction, actually Ki reacts with H2SO4 to give Hi, okay. Hi is not left, okay. If Hi is left alone, it will react automatically with ROH to give Ri. But Hi is oxidized again, okay, using the nascent oxygen. Nascent oxygen means the O symbol inside the box. Hi is oxidized and it gives I2. I2 cannot react with ROH, okay. So that is why H2SO4 is not used, because it is strongest oxidizing agent. So H3PO4 is used to give Ri.